Calculating percent composition is using the total mass of an element in a compound divided by the total mass of the compound times 100%, and that gives you your percent composition. You will use the formula masses or molar masses. Use percent composition as a conversion factor between component mass and compound mass. How many grams of copper are in 20.0 grams of copper sulfate pentahydrate, CuSO4 5H2O? Okay, so if you've got 20 grams, is it 5 grams that are copper? Is it 10 grams that are copper? Is it 0.2 grams of copper? We got to find that out. And we find that out by first calculating the mass of our compound, Cu, which has a mass of 63.546, or I'm going to stop at 2 decimal places, 63.54 grams per mole. S is 32.06 grams per mole. Oxygen, we've got 4 oxygens. Actually, heck, we've got 5. Well, we've got more than 5 oxygens. We've got 4 oxygens here, and then we've got 5 there. So that's a total of 9 oxygens. And oxygen has a mass of 16 grams per mole. I'm going to multiply that by 9. Hydrogen, we've got 2, but then we've actually got 5 water molecules. So I'm going to say we've got 10 hydrogens, and each hydrogen is 1.008. Yep, 1.008 grams per mole. Multiply by 10. Okay, so I'm looking at my total mass of this copper being, of this copper sulfate heptahydrate, 63.54 plus 32.06 plus 9 times 16, well, parentheses, 9 times 16, and then plus 10 times 1.008, close parentheses, equals, I got a total mass of 249.68 grams. So that's the total mass of my compound. Now, what I want to do is I want to take the mass of my copper, which is 63.54 grams. There's only 1 copper in here. And then the total mass of my substance, which is 249.68 grams. Okay, Cu, and then formula. Well, I'll just write it like that. Times 100 equals that. That will give me my percentage. 63.54 divided by 249.68 times 100. I'm going to be at 25%, or 25.4%. Okay, so what I can do now is figure out, well, 20.0 times 0.254 as my percentage, and that is going to be times 20, that's going to be 5.09 grams are copper. All right, next example, how many grams of methane, CH4, can be formed from 100 grams of carbon? Okay, so now this is kind of a backwards question, because what we're looking at is we need to look at, well, if we have 100 grams of carbon and presumably an unlimited supply of hydrogen, well, how much methane can we make? So methane has a mass that is, well, carbon is 12, and there are 4 oxygens, or sorry, 4 hydrogens, plus 4, that's 16, okay? So carbon, 12 divided by 16. So we got the mass of our carbon divided by the mass of our methane, C divided by CH4, okay? Times 100. That's going to tell us that, well, I'm kind of using some not really rounded numbers here, so 12 divided by 16, it's going to say that methane is 75%, or sorry, carbon is 75% of the overall mass of methane. Okay. Now the question is, if our carbon, if we had 100 grams of carbon, well, if we had 100 grams of carbon, well, how much CH4 could we make? And so one of the ways that we can look at this is we can say, or we can set this up almost as a dimensional analysis problem. Okay, so we have a percentage here. We also have an amount of carbon that we're starting with. So what I'm going to do is I'm going to say, if you have 100 grams of carbon, and I'm going to ask the question, if you have 100 grams of carbon, how much CH4 can I make? So what I need to do is get my grams of carbon to be in the denominator. Well, I know that 75% of the mass of methane is attributed to carbon exclusively. So what I'm going to do is I'm going to say 75 grams of carbon per 100 grams of CH4. So this is if you made exactly 100 grams of CH4, 75 of those grams would be carbon. In this question, what we're doing is we're starting with the amount of carbon. So what I'm expecting is, or the way that I'm thinking about this is, if I put in 75 grams of carbon, I'd be able to make 100 grams of CH4. Okay. Now, by putting in 100 grams of carbon, I expect that the mass, the total mass of CH4 that I make, is going to be higher. So I'm going to say 100 times 100 is equal to 10,000 divided by 75. That's going to get me 133.3 grams of CH4. Now this is a little bit of a challenging problem because you kind of have to do some mental gymnastics because you're bouncing back and forth between percentage and grams and percentage and everything like that. But this is what you would need to do. You need to figure out, first of all, that fundamental mass of your individual atom versus the total. Use that to get a ratio, multiply that by 100 to figure out your percentage. That percentage will tell you the amount of that one atom per 100 grams of this substance, which is what we used as our conversion factor there. All right, I hope this is helpful, and let's keep going.